All right, we are now going to cover errors and debugging in this lecture. So errors are a common source of problems for a programmer. These can either be caused by a mistake, so most likely you wrote something incorrectly and there was a syntax error or some sort of bug in your code, or perhaps someone uses your code improperly. So if you're expecting an integer and the user gives you a string, if you're expecting one sort of file type and the user gives you a different file type, these are also errors that can prevent a script from running. And usually you want to handle as many of those errors as possible. So the way Python handles errors, it throws what are called exceptions. So we've seen these before. So if we create a dictionary and we try to access some data in the dictionary, but we haven't actually included that in the dictionary, we get an exception. So Python throws an exception. So this right here is what we refer to when we're talking about an exception. And the type of exception, the exceptions come in different types or flavors. And so when you try to access data in a dictionary that doesn't exist, you get what's called a key error. So this is a type of exception, so you can get this in different places as well. It's not just dictionaries that can throw key errors, but this is the type of error that should be thrown if there's something wrong with the key of a data type. If you have a list, so now we've created a list, and let's say we try to access an element in the list that doesn't exist. So you've also seen this before. This exception is called an index error, and so that makes sense. A list doesn't have keys, it has indices that we use in order to slice and get our data. So if the index doesn't if the index doesn't exist, Python throws an index error type of exception. Let's try to add two data types together that are not able to be added together. So we've created a string and we try to add an integer to it. And so this is a type error. So there's some sort of error involving the two different types, and so you can only concatenate a string, not an integer, to a string. So in all cases, Python throws what is known as an exception, and if you want to see kind of different types of exceptions, there's a huge number of them that Python is able to throw. So some of these we've already seen. We've seen key errors, index errors. If you fail to import a module because a module doesn't exist, we've seen import errors. Input-output errors related to some sort of like file input or writing a file, reading a file. Memory errors. This is if your application runs out of memory. So if you try to create an array that is so large it doesn't fit in RAM, you get this type of error. So there's really a large numbers of different errors that occur. So what happens typically when Python throws an exception is that, especially when you run a script, is that the script stops running. And so, you've seen this when you try to run your script and, you have some sort of error. It reaches that point, it throws the exception, and then it goes back to the command line. So let's see. You can handle exceptions. So when exceptions happen, you can add code that is able to what's called catch the error and do something in order to fix the problem. So this is a very common procedure in writing Python scripts, is that very often you try to handle errors that might come up. So you might anticipate something that will go wrong with the data, or something will go wrong with how the user uses your script that is predictable, and you handle it and do something in order to fix the problem. So let's see how this might work. So let's say we have a string of DNA and we want to count how many A's, C's, G's, and T's. And so we want to use a dictionary in order to keep track of that. So we can do that. So we can loop through every single letter in that string of DNA, and we can try to add 1 to the dictionary, for every A, C, G's, or T's. So if we run this, we try to run this, and we get a key error. And so that's because the dictionary doesn't have A in the dictionary yet. So how do you handle this? So one thing you can do is you could use if statements if the key is not in the nuclei count. So if letter not in nuclei count, we could do something then. But you can also fix this by catching this key error. And you do this using this try except form. So what we're saying is we want Python to try to do something. So try to add, why is this? So try to add 1 to the dictionary, but if that key doesn't exist, if a key error exception is thrown, then do this instead. So this is called catching the error. So Python throws the error to let us know that something is wrong, and typically that causes the program to quit. But instead, we're catching it, and we're saying, OK, this is what we want to do if that happens. So what we want to do is initialize new count letter equals 0, and then add 1 to it. So now we're able to run that, and so now we can see that we properly get the count of all the nucleotides in this DNA. So there's 5 A's, there's 3 C's, there's 8 G's, and there's 2 T's. So what we've done is we've added a try statement before attempting to increment the dictionary. So this will only handle key errors. So what do I mean by that? So let's try to do this again. So let's try to do this loop again. But let's say I want to change my dictionary. So I want to have a second dictionary. And then accept key error. Messed that up. So this should have been 2. So we try to go through every letter, and then we try to increment this dictionary. But in this case, we've never created that dictionary. So we've never done this to say that we want to create a dictionary. And so instead of throwing a key error, Python is throwing a name error because we've never defined this dictionary. And so this exception is not caught by the except statement. And so in the end, if this is a script, the script would actually quit. So what we can do is something like this. I'm going to fix that error that I had before. And now we can add an additional except statement for the name error. And so now if this occurs, we can do something like this. We can create the dictionary, set it equal to 0, and then increment it. So now we've seen we managed to do that. So you can list as many of these except statements that you want, and if any of those are thrown, it will capture that exception, and then it'll do whatever code is within there. You can also do an except statement. So here, an else statement. So this, runs if none of these exceptions actually happens, and then you can say do this, if nothing is an error. So that's another thing that sometimes is useful. Two final things to cover. So you can also try so if we try to run this, if we don't provide it with the type of exception we want to handle, then this except statement will capture any sort of exception, that whole list that you saw before. Anything is caught, and then you run that code. So you can see we looped through this entire thing of DNA. We tried to do this, and every single time an error occurred, and so it just printed this out. And so we never actually created this dictionary because we didn't properly handle the exception. But this is also a way, you typically don't want to do this. This is considered poor form, poor coding style to capture every single error. But sometimes it can be useful during debugging and kind of like getting your script running to just kind of have this generic statement that you can then fix at a later date. So sometimes you might not know what exactly it is. All right, and you can also raise an error as well. So if you want an exception to be thrown, then you use this raise command, and then this raise command will throw an exception, and then you can, say what exactly, the statement that gets printed out. So here we saw index error, list index out of range. So you can also send that information as well. All right, so try except statements. So this is how to handle exceptions in your scripts, and this is kind of the Python style of, it's kind of called asking for or begging for forgiveness instead of asking for permission. So this is kind of the style of how you typically want to do things in Python. So instead of testing before if something is a string or something is an integer, you just go ahead and try to do that, and then you catch the error if there's something wrong with it. All right, so next we're going to cover debugging.